All right. Hello, everybody, and welcome to our next session, which is going to being about ingesting multi-chain DeFi by Ringo. So yeah, Ringo, the stage is yours.
Hi, everyone. Thanks for coming to my talk. So to start off with, I want to go over an agenda of what we're going to be speaking about today. First thing we're going to do is a quick intro on the speaker, which is me. Next, we'll talk about Gauntlet briefly, what we do here, what our mission is. And then we'll talk about existing solutions to this problem of ingesting multi-chain DeFi. Next, we'll go over some dependencies of the solution we built. And then we'll go over the architecture of the solution we built, as well as some of the properties, some of the important properties that the architecture enables or possesses. And lastly, I'll go over some code examples of like how you can actually use the library itself. Cool. So to give a quick intro about me, my name is Ringo. I'm an engineering lead for the data platform team at Gauntlet. In the past, I was an engineer working on video calling at Meta, and I have both my master's and my bachelor's in computer science and engineering, respectively. So first of all, what is Gauntlet and what are we trying to do? So our mission is to actually drive adoption and understanding in the financial systems of the future. The way we do this is by building a platform for off-chain intelligence to power on-chain efficiency in DeFi. What does this mean? Well, this is a high-level diagram of our platform. As you can see here on the bottom left, we have the blockchain, and we ingest data through this data ingestion piece into our data warehouse. We then combine the data we've ingested with proprietary models we developed in-house to run simulations on different client protocols. And the outputs of the simulations are parameter recommendations, which we can then give to the client protocols to make their protocols more efficient on-chain. Today, we'll be focusing on this bottom left part of the diagram here. And in particular, this middle piece of data ingestion. How do we actually ingest the data required to power these simulations and put them into our data warehouse? So first of all, let's talk about why we don't just use existing solutions. There's tons of third-party data providers within DeFi, and you might be asking, why don't we just use them? Well, here's some examples of some of the existing providers. A couple of problems we've noticed with them in the past is that they don't have exactly the data that we need. The shape might be a little different, and there's no way to kind of get exactly the data we needed from the third parties. And so we decided to go on chain directly. Another problem is that these providers might be unreliable or incorrect on certain days. And because of the way our system runs, we actually need very high reliability in order to run the simulations every day. If the simulations are not able to run, then we can't give value to our customers who are paying for it, and we will have a pretty big problem there. So let's now jump into some of the dependencies before going into the actual solution we built in-house. There's 3 dependencies I want to talk about today: node providers, Ethereum RPC, and Web3 Pi. So first of all, node providers. As many of you probably know, working in blockchain, running a blockchain node is very difficult. Here's some provider examples on the right, some pretty famous names. You probably use some of these yourself. Essentially, blockchain node providers are like AWS for Web3. Because running a blockchain node is so hard, most startups are not going to invest resources into doing this themselves in-house, and they'll outsource this process to a company like Alchemy, Infura, QuickNode, or ChainStack, and we'll just pay them for access to the blockchain. And they take care of all the difficulties around running a node. Next, we have Ethereum RPC. This is a specification for interacting with a blockchain. So if I wanted to get some data about, let's say, a block on the blockchain and what happened within that block, I would use the ETH get block by hash function here on the right. Similarly, I can make ETH calls to make arbitrary contract calls, as well as ETH get logs to get different log events happening over different block ranges on the blockchain. It's important to note that all EVM compatible chains implement this spec. And this is really important for us because if you recall, the title of this talk is Ingesting Multi-Chain DeFi, and we actually have clients across multiple chains. So our data ingestion piece must support being able to ingest data across multiple chains. And because the spec is implemented by all EVM compatible chains, we're actually able to get a lot of that functionality for free. And I'll go over how that works later on. Last thing before we jump into the architecture is just Web3 Pi. So this is a Python library for interacting with Ethereum. It has a lot of utility functions, especially around translating between human readable and machine readable formats. The EVM typically operates in like hexadecimal. So a lot of the data you'll see there is going to be in hex. Whereas we have things like AVIs, which are kind of more human readable schemas with strings explaining what the name of different events are, what kind of fields they have, and it's all kind of just in like plain English. So this library is very helpful for us in order to do those translations. And I'll show kind of some code later on as to how exactly we're using this. So without further ado, let me talk about the architecture. So over here on the left, we have a developer that wants to make, let's say, n RPC requests, right? And the main interface that we expose in our library is called EVM RPC. What EVM RPC will do is that it'll take those n RPC requests and create some number k of threads, right? In this example, I've used k equals 4. It will then distribute the n requests over batches of size m, where m is equal to n over k. What that means is we're essentially load balancing, or you can think of it as like a distributed RPC requesting to different nodes of the original request that came in. And in this way, each of the providers handles a smaller subset of the n requests that came in. And then we then join the results on the right here from all 4 of the threads once they complete. And we get the n responses, which we then write to our data warehouse. So this is kind of the high level architecture of our solution that we built, which we call internally Web3 ETL. And I'll go over some properties of this solution, kind of why we built it this way and like what advantages it's been giving us here at Gauntlet. So the 4 properties I want to focus on today are reliability, scalability, multi-chain support, and visibility. And just to remind you again, we're focusing on the data ingestion piece right here. First of all, reliability. Why is this important and what does this mean? So as you recall, the Gauntlet platform, the data ingestion piece in the Gauntlet platform sits upstream of the simulations, which sits upstream of the value we're providing to our customers. Therefore, it's extremely important that our data ingestion piece is highly reliable and runs on a daily basis. How does this architecture enable that? Well, let's say, for example, that one of these providers goes down on a given day, right? How does the system kind of work around that, or like auto heal in that case? You can see here that if Alchemy went down, we just have less threads and we can still send the same n requests over other providers and just have larger batches of size m each. So in this way, any node provider failures are actually not really affecting our system at all because of the way we do our distributed load balancing. Next, I want to talk about scalability. So what happens as we increase n? Let's say the n here, when we're doing our prototyping, it's maybe just 10, but then as we start ramping up our bandwidth and our throughput on production, our n is going up to 1,000, 100,000, maybe even 1 million. How does the system enable that kind of scale? So let's say that we increased n a lot from this original base diagram. What we can actually do is we can add another provider to the system for very low cost. And then now we created extra threads and we have more providers that are able to handle the larger amount of n RPC requests coming in. Next, I want to talk about multi-chain support. So here's an example of some of the chains that we're ingesting at Gauntlet on a daily basis because we have clients which our protocol is deployed on these chains. And in order to run simulations accurately for these clients, we need data from all of these chains. And so the main way that we do this actually is that the EVM RPC understands under the hood and has configuration for which providers have endpoints supporting which chains. Let's say we wanted to ingest some data from Avalanche. Then perhaps Infura and Chainstack are the only providers that support Avalanche. The developer does not need to know this. They just send their RPC request with a chain to EVM RPC, and under the hood, it takes care of everything. Let's say you want to do Binance, then the RPC interface would abstract this away as well, or Ethereum. As for how we actually add providers to the system, we can see that we're adding new providers to this configuration file here, and it's actually really easy to do. It takes about 5 minutes to add a new provider, and each time we add a provider here, our system will automatically work around it and become more scalable and reliable because it doesn't matter if any provider goes down, we just distribute the requests over the other providers. Lastly, I want to talk about visibility. What does this mean? So with any production system, it's really important that we're able to understand what's happening in production on a given day. We want to instrument our production system so that we can debug, so that we can understand load request patterns and make strategic decisions as to how we move forward as a company around our data ingestion piece. So what we do here is actually we instrument in the EVM RPC, and we're able to output stats on the right here. You can see schemas of the stats. We can output things like the method we actually made, like which RPC method we made. We can store parameters like what provider, what chain, and whether or not that request succeeded or failed. And this is actually really cool because it lets us generate some data visualizations on our production RPC request usage, which I'll show you now. So here's one chart showing our total number of RPC requests by chain. As you can see, we're still mainly making requests to the Ethereum chain, but there's a significant portion on Optimism and Binance Smart Chain as well. Here's another chart showing our RPC request count by day across all chains. So as you can see, it's actually not static every day. And this is just because we will do development on some days where we're running ingests on a development environment just to test things. We also add clients over time and we ingest from more deployments over time. So this number should only be going up. As you can see, on November 10th, we ingested around 5.5 million RPC requests, which kind of shows that this number is going to go up over time. And it's really important that our system here is scalable and is able to continue to ingest more and more data. Lastly, this chart shows the Ethereum RPC requests by node provider. And so you can see here that this is a great example of what I was talking about before, that each node provider is not able to service the same amount of throughput or requests. So you can see here that in this case, we actually service a lot more requests from ChainStack, Alchemy, and QuickNode, as opposed to Infura, Coinbase Cloud, and Blast. What this means, or what this enables us to do, is also to make strategic decisions around which providers we want to be investing more money in and upgrading plans on, because we want to make sure that ideally, like, all these bars would be pretty high up and are able to handle roughly equal amounts of load. Obviously, in production, this never happens because there's a bunch of servers and they might be handling a bunch of load on the node provider side. And so this just gives us an idea of how we can move forward around adding new providers and which providers are working better for us versus other ones. Cool. So last thing I want to talk about is just like, how do you actually use this library? So here is an example of the compound ether contracts on Etherscan. And there's a balance of read contract method on this smart contract. And what this code here on the left does is it actually makes contract calls to this balance of method for different owner parameters here. So this owner address parameter is the same thing as the for origin accounts here. And so this code on the left here is equivalent to calling this method on the right for however many accounts you want to call it for, which in practice for us is often in the 6 figures, like let's say 100,000 accounts per day. We want this balance. Obviously, it'd be very difficult to go to this UI 100,000 times and try to input different accounts. And so I want to do this programmatically. So with one line, you instantiate the EVM RPC, which has all this configuration under the hood of which providers to go to, as well as how to batch and how to do the multi-threading. And you simply call batch ETH call generator with 2 parameters. The first parameter being what exactly is the method that we're trying to call. And that's what call balance method is. It tells EVM RPC to call the balance of method on this contract. And then the second one is just which block number we want to get data for. And so this code here on the left is equivalent to calling this stuff on the right, like clicking here on the right, any number of times, n times. A second usage here is for getting log events. So this would be the ETH get logs method. So you can see here under method equals ETH get logs on the bottom of the code side. On the right here, you have the exact same smart contracts, the compound ether smart contract, as well as all the log events emitted by the contracts within, let's say, a 5-minute period. As you can see, there's already 5 events in the 5-minute period. And so your question might be, how do we then get all the events over a period of, let's say, a day or a month, which might number in the tens of thousands or hundreds of thousands? So this code on the left does exactly that. You instantiate the EVM RPC, which has been done before this code block. And you have to do a little bit of transformation here for log events. We utilize Web3 Pi here, specifically the construct event filter params method. It actually tells the RPC request to look for only certain event types. And then we do a batch raw call generator with those parameters and get logs. And we're actually able to get like all the logs matching any type here over any time period programmatically and ingest it into our data warehouse. So those are just 2 kind of examples of how you might use Web3 ETL. So, in conclusion, wanted to outline some key takeaways from this presentation, which are that on-chain data is necessary for DeFi, but ingesting it is non-trivial. And we built a library for our use case at Gauntlet, and we'd love to hear from you if you're working on similar problems, because we've invested a lot of time building this library, and we found it very useful ourselves, but we'd love to open source the code and collaborate more if the community finds it useful. So please contact me at my Telegram or email us at our email down here in the bottom left. And thanks so much for listening to my presentation.
Yeah, thank you so much for sharing. And if anybody has questions, feel free to put them in the Discord channel and we can get to them here. And somebody's typing, so we might have a question soon. Okay, so the question is, your multi-chain ingestion seems to be on-chain at a time. Would the Web3 ETL library be able to combine results from multiple chains at once, for instance, getting the balance of an address?
That's an interesting question. So make sure I understand the question properly. You're asking if we are able to combine data ingested from multiple chains. Is that correct?
Well, I think it seems so.
Okay.
If not,
Yeah. I mean, no,
they will
that's a great
ask
question.
again.
Yeah. So that's a great question. The answer is the EVM RPC itself doesn't take care of that, but within our data warehouse, once we have ingested data from different chains, we can then do joins across. So we actually store our stuff in BigQuery, which is like essentially like a Google Cloud version of SQL. We can then do joins across different tables in there in order to get the data that you just mentioned right now, which is like, how do you correlate data across different chains? So that's probably a solution we would, like, that's probably what we would do if we needed to do that.
Okay, I hope that answers the question. If not, the channel remains open. Okay, maybe while they type, I think you had like a Web2 career and then you pivoted to Web3. Any main takeaways or challenges you faced, or maybe recommendations for people trying to do the same?
Yeah, challenges I faced. I think definitely it's something that I consciously wanted to do and I thought about for a while. I would say it's definitely more difficult being in this space due to the volatility of the markets. So it's important. At least it was really helpful for me to build that conviction before like entering the space, especially given that I joined in May and the space has kind of like taken a pretty precipitous like turn shortly afterwards. That's one advice I would have. And then second is just like there's so many opportunities within Web3 that I didn't realize before I started looking. So if you're even just curious, I would say like there are tons of good resources out there and lots of companies, like lots of great companies hiring. So would love to chat about that too if like people wanted to chat with me more privately about their situation. Yeah, so hopefully that kind of helps.
Encourages a few, hopefully. I mean, in May, that's really like you joined before all the crisis went down, basically.
Exactly. Yeah. I had made the decision to like join Web3 in like February, and I didn't start like this new job until May. But yeah, it was interesting timing.
Yeah, for sure.
Oh, I see.
Okay, so yeah, adding on to the previous question, so it's like another one is to clarify the load balancing abstraction that was described earlier is only one chain at a time.
That's right. Yeah, typically a pipeline or a developer would be making a bunch of like those NRPC requests from the slide earlier. I can go back actually. Maybe that's helpful. So like going back to this diagram here, you know, like these requests would be for a certain chain, and then the RPC would rebalance them across different providers. But you could easily write code that like does this, and then right afterwards like makes requests for a different chain too. Yeah. Oh, I found the channel actually. So he's saying,
yeah,
multiple connections with async IO, great addition. Yeah. We actually use like the concurrent .futures library in Python to actually like do the threading and like load balancing across different chains. But yeah, there's nothing stopping you from just like sequentially kind of like making requests for one chain and then for another right afterwards. Yeah, it just wouldn't be balanced across different, like you wouldn't send them in the same function call, if that makes sense.
Okay, I hope that addresses the questions. And if not, there will be a face-to-face, so you can ask further questions and any other recommendations or whatever else is on your mind when it comes to multi-chain, DeFi, and anything that's related, really. Yeah, thank you so much for being here today and for your time and sharing what you do at Gauntlet. I think it's pretty exciting. I mean, you have all the blue chip DeFi apps already using your product, so that says quite a lot. And yeah, we'll share the face-to-face link, so anybody interested can talk more about that there.
Sweet. Thanks so much.
Thank you so much and have a good day.